Right. So, the last session we talked about non-probability sampling. We also said there are 4 kinds of probability sampling. We'll start from there here. Right. Just to refresh your memory, probability sampling methods are preferred for quantitative research because you can calculate the probability of any one person being selected. It also calculates something called the likely error. Right. We will come to these concepts later when we talk about the basic statistical fundamentals based on which market research sampling is done. We will come to that. For the time being, let's just remember this and not worry too much about it. So there are 4 kinds of probability sampling. There is simple random sampling. There is systematic sampling. You can also say systematic random sampling. You can say stratified random sampling. You can say cluster sampling. Right? And there's another name for systematic sampling, which is probability proportionate to size, or PPS. Probability proportionate to size literally means that the probability of any one sub-target group coming in our sample, it will come in the same ratio as it is there in the population. Okay, we'll work out an example to explain what I mean here. Okay, so far 4 kinds of probability sampling. Let's go forward. Okay. So simple random sampling is a traditional sampling. It is widely considered to be the purest form of sampling. Sadly, it is rarely used in practice. Okay. Technically speaking, theoretically speaking, simple random sampling has got 2 conditions which need to be met. 1, every element in the sample, in the population, that is every person in the population, right? As I've said repeatedly, the technical language is every elements. We are talking about people. Every person has an equal chance of being selected. Plus, every combination of people has an equal chance of being selected. So, if the sample is to be selected in a class of 20 and you need to select 5 people, right? It can be 1, 2, 3, 4, 5 or 2, 3, 4, 5, 6 or 3, 11, 16, 18, 20 or any combination of 5. All those combinations will have an equal chance of being selected. Okay, equal, and theoretical literature will talk about equal and non-zero. Nobody has 0 chance of being selected. If these 2 conditions are met, it is called simple random sampling. Okay. In actual practice, we don't use it very often, in market research at least. And there are 2 main reasons for that. Simple random sampling requires a very good sampling frame. By sampling frame, what do I mean? Can one of you tell me that?
It is a list from which the samples are.
It is a list of all the people in the population from which we draw the sample. The list may not be perfect, but the more complete the list is, the more accurate a sample will be. The point is, in most market research studies, you may not get a perfect list. Right? If you have a list of, let's say there's a company bank lending money to people, it will have a perfect list of all the customers. In those situations, you can do a simple random sample. But very often, otherwise, you won't have that kind of list. But even if the list is complete, there is another problem with simple random sampling. Simple random sample, the program will give you that you must interview person number 16, 25, 311, 462. It will indicate which serial number of people are to be interviewed. Now, if you don't get those people, you can't very easily substitute with another person, because this method is so strict that it doesn't have much provision for substitution. And because it is so strict, in practical applications, it is not always used. Because in real life, you cannot afford to be so strict as like the textbook. Right? So these are the 2 reasons why we don't use simple random sampling much. Now, when I was back in college, when we talked about 34 years ago, we were taught how to draw a simple random sample using something called random number tables. Frankly, I've forgotten that now. I don't think today people need to know it because there are good computer programs, easy to run computer programs that will generate a simple random sample for you. You just feed in all the serial numbers, it will give a simple random sample of serial numbers for you. So, I don't think it's necessary for us to know that. Those days they're gone, right? They've been overtaken by technology. Okay, so far? We'll go forward. Let's go to systematic sampling. Now this, as I said earlier, is something which is used extremely commonly. Now here what happens is, the first person in the list, and this also needs a list, a sampling frame, the first person is selected maybe at random, completely at random. You can just select serial number 1. You can make it a rule, I always select serial number 1. Nothing wrong with that. After that, the second and third and fourth person in the sample is selected in a pre-decided order. What is that order? For example, if the population size is 100,000 people, right? And if we have to select 100 people, okay, then the first person, just for example, let us say serial number 83. The next person will be 83 plus 100,000 divided by 100. So we'll take every 1000th person. Because 100,000 by 100 is 1000. We will keep taking every 1000th person. Okay? And if you go down the list, we'll end up with 100 people. This is called systematic sampling. So it is a pre-decided order. Now, here also, every person has an equal chance of being selected because the first person is selected at random. Right? But every combination doesn't have an equal chance of being selected because 1 and 2 can never come. Because it can only be 1 and 1001. And so on and so forth. Right? So this is used a lot in commercial market research. Whenever we do customer satisfaction studies, for example, from a database of customers, right, we use systematic sampling. And it's done very, very commonly. Right? So it is something which you really need to be very familiar with. Okay? Now, why is this called probability proportionate to size? PPS. We shall see that in the next couple of slides. Let us take the same example. 100,000 is a population. Let us say it is only 3 states. Sorry, we have to go back. Let us say it is only 3 states. Right? Let us say it is Maharashtra, Karnataka and Tamil Nadu. Okay. Let us say Maharashtra has got 25,000 people. Karnataka has got 35,000 people. Tamil Nadu has got 40,000 people. Okay. Now we have to select just 20 out of this 100,000. Okay. What we'll do is we'll first give them serial numbers. State Maharashtra people will give them serial number 1 to 25,000. Karnataka people will give them 25,000 to 60,000. It's 25,000, 35,000, right? Tamil Nadu people will give 60,000 to 100,000. So 25,000 plus 35,000 plus 40,000 become 100,000 people. So far, okay? Okay. So now tell me, in the previous example, I said every 1000th person. Here what it should be. We need to select 20 people from 100,000. No. It was 100,000 by 100 there. Here?
Okay, 100,000 divided by 20.
Yes, which is every 5,000th person. Okay, so let's go to the next slide. Again, let's just say the first person we got at random was 83. Serial number 83. Okay. So the second element will be 83 plus 100,000 by 20. That 83 plus 5,000, that is 5,083 and so on. So all the 20 serial numbers are here. 83, 5,083, 10,083, blah, 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 up to 95,083. Okay, now we know that serial number 1 to 25,000 is in A. So all these people are A. Yes. We know the serial number 25,001 to 60,000 is in B. So all these people are in B. We know the serial 60,001 to 100,000 is in C. Therefore, all these people are in C. Now, how many people are in A? 5. How many are in B?
12.
In B?
12.
12?
7. 7.
7. How many people are in C?
8.
8. Now, what is 5 is to 7 is to 8? Is it the same as 25,000? Is to 35,000? Is to 40,000? Right? So, which is why state A has contributed in the sample equal to the ratio in the population. Likewise state B, likewise state C, which is why it is called probability proportionate to size. When you use this method, right, you have an excellent likelihood of getting that every segment. Here in this example we use state. Something could be men and women, something could be rich and poor people, something could be older and younger people. They will all contribute in that proportionate ratio to the sample. Right? That's the advantage of this method of sampling. Clear? We'll go forward. So the same point is, I've just explained that here. We ended up with 5 elements in state A, 7 in state B, 8 in state C. The population ratio between the 3 states is 25,000, 35,000, 40,000. So this method, each state is represented in the sample in a proportionate fashion. This is the reason why we use the sampling method so often. We won't go wrong in our ratios. We won't get too much here or too much there. The method of sampling will look after this problem for us. Okay. Interestingly, in this example, just to make it easier, I said serial number 1 to 25,000 is A. Just to explain the thing. Actually, even if you don't do that, it will still come. Even if you just put them in any random order, it will still come in the same ratio. I'll leave that for you to try as a home assignment. Okay. Have you understood systematic sampling?
Yes.
Okay. Here we are with stratified sampling. Here, we divide the population into mutually exclusive and exhaustive subsets, which we call strata. Now, can you tell me what these two terms mean? Exclusive and exhaustive. So, exclusive means every person in the population can belong to only one or the other stratum. The singular is stratum, the plural is strata. Every person can belong to only one or the other stratum. So they are exclusive. People cannot belong to more than one stratum. Okay, this is point number 1. Point number 2, exhaustive. Exhaustive means every person will belong to some or the other stratum. Right. So let's talk about stratified sampling. The population is divided into mutually exclusive and exhaustive subsets. Okay? And this is known as strata. The singular is stratum. The plural is strata. Now, can you tell me what the terms mutually exclusive and exhaustive mean? You will find these terms very common in statistics and therefore very common in market research as well. Whenever. Okay, so mutually exclusive means one person in the population can belong to only one or the other stratum. They're exclusive. The people who are in this stratum cannot be in this stratum. They're all exclusive, the stratum. What is exhaustive? No person is left out. Everybody must belong to this or that or that or that stratum. Nobody is left out. It's exhaustive. Exhaustive in the sense that we're using it here, the English word means complete. An exhaustive list means a complete list. It is not the same as exhausting, which is tiring. It is not the same as exhausted, which is tiring. The root may be the same, but we need to understand the meaning of the word in the context here. Right? So this is mutually exclusive and exhaustive. So you divide the population into stratum A, stratum B, stratum C, stratum D. And then which in each stratum? You select the sample. And that sample can be simple random sampling or systematic sampling. Doesn't matter. So some from here, some from here, some from here, some from here, and you put together for the total sample. Right? This is stratified sampling. Now, how do you divide them into strata? You use any criteria of relevance, and this is one of the most important concepts in sampling. This is not statistics, this is common sense, right? And it is extremely important to understand this. Okay? Now, if we are trying to understand a study, if the study's objective is to find out what percentage of Indians have black eyes versus brown eyes versus green eyes versus blue eyes. Let us say that is study objective. Okay? Will you divide them based on upper income, middle income, lower income? You won't. Because a person's income is completely irrelevant to the person's color of the eyes. Correct? However, if you want to find out what percentage of Indians have fair skin versus darker skin versus dark skin, then you will include the state from which they come. Right? There is no harm in accepting a common fact that people who are from states like Kashmir are on general fairer than people who are from states like Tamil Nadu, for example. This is not racism, it's just a fact. Right? So, you must select strata based on criteria of relevance. If the study is to find out what percentage of Indians have costly cars, then you will divide them into strata based on income, because that's a relevant criteria. So, this is common sense, right? Statistical principles don't tell you anything here. You have to apply your common sense. I said, what are we trying to measure? What can be the variables that affect that thing? And you build strata based on that. Is this clear? You will have to apply some examples to understand what this is. It may look very obvious, but in the middle of doing something, it is easy to lose sight of the fact that common sense needs to be applied here. Okay? Now I'm going to introduce two more extremely important terms. To achieve the best results from stratified sampling, in fact, the concept of stratified sampling is itself based on this. As much homogeneity as possible within each stratum, and as much heterogeneity as possible between strata. What do you think I'm talking about here?
In stratum, they will be having a similar characters.
Excellent.
Between the strata, they will be having a different character or different
characteristics. It's important to use the correct word, characteristics. Very good. So, homogeneous is just a technical term for saying similar people. So, within the stratum, the people will be as similar as possible. Between the stratum, people will be as different as possible. Okay? Again, different on what? Similar on what? What are those characteristics? We are back to the same criteria of relevance. If the study is to find out what percentage of Indians are fair skinned and all, then people from all one state will be in one stratum. People from another state, or you can even say one zone, another zone. But criteria of relevance. If the study is to find out what percentage of Indians have costly cars, then people from upper income will be one stratum. Or you can even take very, very upper income and somewhat upper income. And then you can say people from middle income will be one stratum. So on the criteria of relevance, people within the stratum will be similar. And they'll be from stratum to stratum to stratum, they'll be very different. Okay?
So,
yes.
Is there any possibility that within stratum, the people will be having different characteristics?
on the relevant criterion, they shouldn't be. Somebody could be tall, somebody could be short. That doesn't matter. Somebody could be right-handed, somebody could be left-handed. That doesn't matter. If you're measuring income, those things don't matter. If you're measuring costly cars, those things don't matter. But if you're measuring costly cars, and if income is your criterion of relevance, then you will not have upper and lower income people in the same stratum. Because then it's no longer stratified sampling. By definition, it is not stratified sampling. Is it clear? I'm going to make one more statement here. We will come back to this. For the time being, just sort of memorize this. Now, the root of the statement is the fact that heterogeneity is the sort of the enemy in a loose word, is the enemy of sampling accuracy. Okay, so I'll give you an example here. Let us say we want to find out percentage of people who use sesame oil in their cooking, coconut oil in their cooking, groundnut oil in their cooking, mustard oil in their cooking. Let's say that's or sunflower oil, rice bran oil, corn oil. Let's say that's a study objective, right? Now, if I select all people who are Tamilians, just for example, then our sample can be 50. Because those people are so similar to each other. Tamilians in general tend to use sesame oil, which is also known as gingerly oil. Tamilians tend to use some degree of groundnut oil as well. And because they are all Tamilians, they may have similar habits. So even a sample of 50 is enough. But if we distribute the same 50 across Tamilians and Keralites and North Indians and East Indians, East Indians tend to use mustard oil. Keralites tend to use coconut oil. People in the metros tend to use sunflower oil. So we distribute the sample, then 50 becomes a little inadequate. So the number is the same. So this goes back to one of our earlier discussions. Is 50 a good sampling number or is 100 a good sampling number? It depends on how heterogeneous the population is. The more heterogeneous the population, you have a larger sample size requirement. The more homogeneous the population, you can manage with a smaller sample size. This is one of the fundamental principles of sampling. Right? Therefore, in stratified sampling, within a stratum, we are ensuring homogeneity. So a small sample from each stratum will still give you good results. Which is why, in a very technical sense, stratified sampling tends to give you the most accurate results. This is clear. I mean, if you can internalize this, it's terrific. If you can't, keep in mind that when the population is more heterogeneous, meaning different kinds of people are there, then your sample size needs to be larger. When the population is more homogeneous, that is, by and large, it is similar people, then it is enough to have a smaller sample size. So if your entire study is being done among second year students in engineering college, and you want to find out what kind of, in engineering college in Chennai, and you want to find out what kind of music to listen to, it is enough to have a smaller sample size because, Tamil is a dominant language here. Some people may listen to English, some people may listen to Telugu. But if your population includes second year students of all kinds of colleges across different states. Now, all kinds of colleges doesn't matter. It's not a criterion of relevance because we don't think students of BSc listen to different music from students of BE. But different states makes it different. Because if you're going to include people from Bengal and Karnataka and Andhra Pradesh and Punjab and Maharashtra and Delhi, some will listen to Hindi, some will listen to Marathi, some will listen to Bengali. And therefore, because your population is more heterogeneous, you will need a larger sample size. Is this principle clear? Right? So in stratified sampling, since we are forcing homogeneity within a stratum, within the stratum the data will be very accurate. In this stratum data will be accurate, this stratum data will be accurate, so put together also it will be more accurate. That's all we're saying. So far so good? Absolutely confident? We can move forward, right? So is heterogeneity a friend of sampling? When this population is more heterogeneous compared to when the population is more homogeneous, which one requires more sample size? Excellent. Why?
It it won't. If the sample size is heterogeneous, we need to collect more.
If the
sample.
population is heterogeneous, now please, get the technical terms right. When the population is more heterogeneous, we need a larger sample size to make sure we cover the different kinds of people. That's the reason why you need a larger sample size. Otherwise, every one kind of person will have too small a representation in your sample. So when the population is more heterogeneous, you need a larger sample size. Correct?